Confused by star schemas and Snowflake schemas? Do you need to know which one is going to be best for your data warehouse? In this video, we'll be breaking down the differences between these two different, very popular data modeling techniques in a way that's very easy to understand for beginners. Even if you're just starting out, stick around to find out which technique will help to optimize your queries and enhance your data management. Let's dive in. Quickly, before we get started, let's just recap what a data warehouse is. A data warehouse is a centralized repository that allows you to store data from various sources. It's designed for query analysis as opposed to transaction. So in another video, we'll discuss the difference between OLAP and OLTP. So just for now, know that OLAP is for analysis services and OLTP is for transactional databases. Within data warehouses, we use schemas and models to organize and store our data for analysis optimization. The most common types of data modeling are star schema and Snowflake schema. The star schema is the simplest data modeling technique. You have a fact table surrounded by dimensional tables. So think of it as the fact table being the center of your star and your dimensions being the points of the star. You won't always have 5, and sometimes you may have more than 5, but the concept sticks. Your fact table, as we've talked about in our previous video, is your quantitative data, while your dimensions are your descriptive data, your who, what, when, and where. So, for example, pretend you have a sales database. Your fact table will be your individual transactions, so all of your sales transactions, while your dimensions will be things like your customer table, your products table, your date table, and maybe your location table. The advantages to star schemas are that it's easier to understand. In addition, it helps with query performance because you're taking a lot of the repetitive text that would be in the one table modeling format and taking it and putting it into a place where it's not as repetitive and it's just an ID that links to that dimension where the text lives. So you don't have as much data lying within that table that you're querying. The disadvantages is that it can lead to some redundancy in comparison to the Snowflake schema that you'll see momentarily. All right, let's talk about the Snowflake schema. So for a Snowflake schema, the tables are a little bit more normalized. This means that the data is split into additional tables. So your normal dimension table will be potentially split into an additional table. For instance, you may have a customer table and an address table. So you might have a table where you have your customer table that has a customer ID, their name, and then a address ID, and then a separate table that has their addresses in it. This helps with things like deciding between which normalized form you would like your dimensions to be in, as well as which slowly changing dimension type you're going to use. So while a customer's name may change very rarely, a customer's address may change a bit more frequently. And so you might want the addresses to be split off into a separate table. So in doing this, you're adding an additional layer to your star schema and creating a snowflake. It resembles a little bit more of a snowflake than a star. You might have a dimension table that splits off into 2 different sub-dimension tables. And when doing that, it starts to resemble more of a snowflake, especially as you get further and further out. You have a centralized fact table. So the fact table, exactly the same as the star schema, holds your quantitative data. So again, your transactions from your sales database that you're going to use for your analytics here. Then you have some normalized dimensions. So again, these are dimension tables that may be broken down into some subdimensions. Another example of a subdimension may be a product table that's split into your product categories and then your product descriptions. So some of the advantages to your Snowflake schema: it reduces redundancy, and it reduces redundancy because you don't have to have all of that additional data in your dimension. So especially for things like the product example that we just used, you're going to have your product descriptions, just a table of very unique product descriptions for each individual product. And then you're going to have a separate table for your product categories. That way you're not repeating your product category for multiple products. You just have an ID that relates back to that product category table. In addition, The Snowflake schema modeling technique also creates the subdimensions, which are a bit easier to maintain and makes it a bit more organized. There's two disadvantages to the Snowflake schema. Those are your queries are going to be more complex due to multiple joins. In addition, you may have slightly slower query performance compared to the star schema. So, the important piece. Choosing between star schema and Snowflake schema depends on your specific needs. So use star schema if your goal here is query performance, or you have a small data warehouse and redundancy is not a concern. You could use star schema here. The star schema methodology is simpler, it's easier to implement, and you have some increased query performance. Snowflake schemas you could use when you need to normalize your data, minimize your data redundancy. You potentially have a more complex data structure. You do have some redundancy concerns and you want to limit the space that's in your data warehouse. Snowflake schemas are better suited for larger data warehouses where you have some more intricate relationships between all your models. Let's look at a practical example. Let's say that you work for an e-commerce company and you need to analyze the sales data. And you're analyzing the sales data to better understand customer behavior. For a star schema, you would create a centralized sales fact table with dimension tables for your customers, your products, and your time. Setup for this would be quick, and this setup allows for quick and straightforward queries. For a Snowflake schema, you would normalize the customer dimension into separate tables for customer details and then for customer demographics. This reduces redundancy, but increases complexity. So for the Snowflake schema here, you would again have a centralized fact table for your sales transactions. And in addition, you would have your customer table, which you may split out between your addresses and then your customer demographics. So again, this starts to look a little bit more like a snowflake as we start to build it out. This does reduce redundancy as we discussed, but it does create more complex queries as you're working through that Snowflake model. Those are the difference between the Snowflake and the star schema modeling techniques. So I hope you learned something from this video. Write in the comments below what your biggest takeaway from this video was. If you have any questions about data modeling, leave those questions in the comments below. It will help others as they read through the comments as well, learn from your questions, as I'll go through and answer them as I can. Be sure to like, comment, and subscribe for other data engineering highlights and topics, and I look forward to seeing you again soon. You've had fun with data.